Hi everybody, today is Friday, March 25th. Here's what's going to happen today. I wrote in my sub-plans that you all will be listening to videos the entire class period and following the instructions. We're going to continue on with Populations and Resources, lesson 1.4. And I actually made two different videos that you see in Schoology. Video number 1 is focused on activities 1 and 2. And then the second video is activity 3, which is actually your homework. I split these up just because honestly, to give you a little bit of a break between the first and the second video so you could stand up and kind of move around. I've got you instructed to do something and then you can come back and focus again. It's a built-in kind of mental break from watching a video. I also did this because if for some reason you're unable to finish your homework in class, it'll be a lot easier for you to come to this second video and continue as opposed to trying to remember where you are in a big long video. You will have a homework assignment that is due on Monday. It's a paper copy of Births and Deaths in the Honeybee Population. It's a worksheet. It is not available on Amplify. I have the worksheets up on front on the table. Do not go get those until you're instructed to in the video, okay? I'm going to start off very quickly by reviewing the 4 key concepts that we have so far. Some kids were not here, and some kids were unable to write down the key concepts, so I said that I would do that. If you have all 4 key concepts, you are welcome to kind of skip ahead and start when we start the lesson. If you do not have the key concepts written down, pause the video, write them down, and then move on. Key concept number 1 is within a population, organisms are always being born and dying. And just a reminder, I'm starting to give you guys the theme for PB1. So if you don't have this written in the red area for PB1, the theme is stability and change. Key concept number 2 is kind of a long one. It says a system can be stable even as things are being added to and removed from it, as long as it's equal, as long as it's even. If the amount being added and being removed are not equal, then the system will change. Key concept number 3 says, if the number of births and deaths in a given time are equal, then the population size will be stable. So this is just really digging into what we did in the key concept number 2. It's kind of just highlighting that first part. And then key concept number 4 states, if there are more births than deaths in a given time, then the size of the population will increase. If there are fewer births than deaths, then the size of the population will decrease. So this is highlighting how a population can change. Okay, you guys, let's go ahead and get started with lesson 1.4, and we're going to start with our warm-up. And we've got a graph that shows honeybee population in the United States, and I want you guys to answer the question below. If I don't teach you anything, if you don't learn anything this year except for this one thing, then please learn this. Anytime you're given a graph, please make sure that you're not trying to figure out what this means before you read the title of the graph or the data chart and the title of the X and the Y axis. So this is the U.S. honeybee population decrease, and this is population over time. Your question is, what statement about the births and deaths of honeybees is correct during each period? And each period means like this blue part represents a period and the yellow part represents a period. Go ahead and read that, answer the question, and hand it in. Okay, so we're in activity number 2 now. Remember, in your role as student ecologist, you're trying to determine why the moon jelly population in Glacier Sea increased in size. If you remember yesterday, we used tokens to model how births and deaths in a population can cause the population to increase or decrease or stay the same size. And if you were not here yesterday, basically we started out with 14 tokens in the circle, and we modeled how a population would stay stable. So that means over time, the same number of births and deaths were equal. If we wanted it to increase, we added more tokens through births. And if we wanted it to decrease, we removed more tokens through deaths. Okay? let's watch a video about how ecologists collect evidence about population changes. So here's the deal. We understand, I hope you guys understand, just a really simple truth that if we have more of an organism going into a population, we're going to have an increase. If we have more leaving the population through death, then we're going to have a decrease. And if it's the same, it's going to stay stable. But how do ecologists get that information? How do they get the evidence about their population? So we're going to watch this video. Keep this in mind. What is she doing in order to get the evidence about the number of organisms in a population? I'm going to pause this for a second. I want to tell you something. In the past, when I try to show a video, while recording the video, the sound lags, and I don't know what else to do for you. If you don't like it, if it drives you nuts, you can go in your digital resources for this lesson, and you should have a digital copy of the video. If you'd rather watch that, go ahead and stop this video, watch that video, and come back. Otherwise, just bear in mind it's probably going to lag a little bit.
Today we're at the Louisiana University Marine Consortium, which is the main center for marine science research in Louisiana. So if we want to understand whether jellyfish populations are increasing or decreasing, it would not be a very effective method for me to sit here and watch the jellyfish float by, counting them one by one. What we really need to do is go out into the ecosystem, and to do that, we need to get on a boat. So today we're going to use the RV Acadiana and go out and try a couple different collection methods that are much more efficient. All right, here we go. We got Captain Carl and the RV Acadiana. All right, you ready to go? All right, let's get out of here. One of the ways that we can collect jellyfish is just directly, which is using a dip net. The way that we do this is we just take a large net that you would use for fishing, and we have a spotter, and they just look for jellyfish that are close to the surface of the water. Oh, I see one. Oh, I got it. All right, I'm gonna track it. Got it. All right, I need a bucket. So after we finish dip netting them, sometimes we'll take them out of the bucket and we'll measure them. And after we finish with it, we take the jellyfish and we put it back in the ocean. There you go. So this dip netting method is really great for helping us answer questions that are about individual organisms, but it's not effective for answering questions that are about the population. So we use a technique called trawling to collect jellies from many different places. The technique of trawling has multiple steps. The first step is we throw out the cotton, which is the back of the net, and the net gets fed out the back of the boat. So then we tow the net for a set period, and then we haul the net in. Perfect. Way to go, Carl. This is exactly what we want to look at. Okay. So we got some fish here, and we have looks like 4, 5 moon jellies that we caught here in the trawl. We can use repeated sampling to estimate the number of jellies that are in our ecosystem. We go around to different places around our ecosystem, and we put a trawl in, and then we bring the trawl up and we count the number of jellyfish that are in that trawl. And so then we repeat this method multiple times. We then can generate an average estimate of the number of jellyfish that are in our ecosystem. Trawling is a technique that allows us to capture the number and the distribution of jellyfish in an instant. But if we want to understand how the jelly populations are changing in time, whether they're increasing or decreasing, we need to sample them repeatedly over time. So for example, we can go out 1 month, let's say January, and we sample a set of sites. And then we'll go out February, and then we'll go out in March. And then by taking repeated samplings, we can then understand how their numbers are changing through the year. And what this allows us to do is develop a time series that then can tell us whether jellyfish in the ecosystem are increasing or decreasing. So these time series that I'm talking about with repeatedly sampled jellyfish are actually very, very important to understanding long-term changes in not only jellyfish populations, but all ecosystem parameters, including fish, crabs, shrimp, everything that we care about. But these time series are really hard to collect. Scientists need help from the citizens, but also we just need more scientists, because the more people that we have monitoring our oceans, the more information we'll have, and the closer and more quickly we can get to answers.
Whoops, let me get to, okay, so a couple things before we get started. Every single year when I show this video, a lot of kids will, one of the first things you probably noticed is that she was handling those jellies and they weren't stinging her. She wasn't wearing gloves. She wasn't wearing any protection. And so I have looked up information and did a little bit of research, and I found out that actually there are a large majority of jellies that do not sting, and they're actually not harmful to humans. They're not poisonous. The problem is we don't know which ones those are, and when you're swimming in the ocean, you don't know, and so it's best to steer clear from them, obviously. But I thought that was interesting. So obviously the moon jelly is not harmful to humans, and it does not sting, so she was able to handle them. So how does the ecologist in the video, how does she get evidence about the population of jellies? Well, first of all, she talked about dip netting. And dip netting is when she just took one net and she was getting one species. She just picked up one moon jelly. And this is really effective for collecting data about an individual species, an individual organism, but it's not effective at all when you're talking about finding out information about the whole population. So what they did is they took that green net at the back of the boat and they did what's called trawling. And so they took a sample of however number of jellies were in a certain location, and they got all the data that they needed to, and then they left that location and went to another location and went to another location. And so they don't just look in one area, they look in multiple areas. And she said they do this repeatedly throughout the year to get really good data over a period of time. So if they had like 4 or 5, 6, 7 different areas that they went to in January, they would go to those same areas in February, March, April, and all throughout the year so that they can get a really good understanding of the average sample over a year, over time. So we're using this word sample. Sample means a small part that's meant to show what the whole is like. We used this word sample, or heard the word sample, when we were listening to the documentary video on Monday. And that was, again, referring to scientists getting an understanding of a small part. Here's the thing. It's really, there's no way that she could go out on that boat and collect every single jelly and count it and understand what was going on in the population. And then she was talking about even other factors in the ecosystem, the crabs and the fish, and there's no way to count all of them. And so you get, you try and collect what's called a sample to show what the whole ecosystem is like. So today we're going to practice using this evidence criterion to evaluate evidence the way ecologists do. This is the same evidence criterion that we've been using all year long, and it says samples that represent as much of the whole as possible provide stronger evidence. We want to know, basically, we need as much detail and that those samples represent as much of the whole as possible, so that gives us the strongest piece of evidence. In this lesson, we're in activity 2, and you guys are going to be in screen number 2. You're going to work independently. I think it says on the directions to work in partners, but because you guys are working on your own today, you're going to work independently to evaluate 2 pieces of evidence about the glacier, or about the jelly population in Glacier Sea. Each one describes a different sample. So to evaluate how well each sample represents the entire population, you need to look at the map showing whether jellies are counted. You're going to also see graphs estimating how the whole population changed over a period of 30 years. And I highlighted this word estimating because, again, it's impossible to count every single one. And so if we have enough samples to represent the whole, that's the best evidence that we could have. So you're going to first read and annotate both pieces of evidence, and then you're going to decide which sample represents more of the whole population. Here's what I'd like you guys to do. I'm going to go ahead and connect to Amplify. Hopefully. Yep, there we go. So this is what you're going to see, and I'm going to trash mine really quickly. Sorry. Actually, let me just pull this one up. I don't think I've got anything on here. Okay, so you're first going to annotate, and I'm going to zoom in here so I can show you what I mean by that. I want you guys to read these evidence cards, and I want you to think about what this evidence means to help you understand which one is the better, gives the best evidence. So you're going to come up here, you're going to click on the plus sign, and that allows me to jot a little note, and then you can grab it and you can move it around. If you decide you don't want a note, you just hit the trash can and then click the X and it'll take it away. So we've got moon jelly evidence card A. The first bullet says every year between 1980 and 2010, ecologists counted moon jellies in Glacier Sea. So I want you guys to follow along and do what I do. We're going to add an annotation, and it tells me between 1980 and 2010, ecologists are collecting samples at Glacier Sea. So I'm going to say Glacier Sea samples over 30 years. Okay? And then click out to the side, and then you can grab this, and I'm going to put this kind of close to this bullet so I know that's what I'm talking about. The next bullet says the jellies are counted in one location near the shore. So I'm looking in this graphic, and I can see in the key I've got a dot here that shows me where the collections were taken, and I've got this little house icon, and that tells me that's at the Glacier Sea Research Center. So based on that information, I can tell that basically the researchers just kind of went out their back door right here close to the shore. They probably didn't get on a boat. They probably just collected the sample just from land, and they only took one sample. So I'm going to add my annotation, and I'm going to say one location sample near the beach. Okay, and then I'm going to move that down here right by my little dot so I can see that. Lastly, I want you guys to take a look at the population over time graph that's right here. So this is the estimate of jelly population change. And so just based on this one location, it looks like the jelly population remained fairly stable and maybe even increased a little over 30 years. So I want to interpret this graph, and I'm going to go ahead and put a third annotation there, and that was it looks like the jelly population remained stable, then increased gradually over 30 years. Okay? If you need to stop this video, I don't like how it did that. If you need to, you can stop the video and go back to see what I wrote again. But basically, I'm just reminding myself what I think, how I'm going to interpret this graph. It looks like the jelly population remains stable, then increased gradually over 30 years. Okay. Now, I'm going to have you guys go ahead and do your annotations for Moon Jelly Evidence Card B. And I'd like you to do the same number of pieces of annotation. So I want you to do an annotation over this first piece of information, another one about the graphic, and then a third one about the graph itself. And then I'm going to come back and talk to you and let you know what I would put in. Go ahead and pause the video and read and annotate. Okay, so let me show you what I would do. For Moon Jelly Evidence Card B, I see in the first bullet, it says every year between 1980 and 2010, ecologists counted moon jellies in Glacier Sea. Well, that's the exact same piece of evidence up here, and so I'm just going to copy and paste that annotation because it's the same bit of information that we got above. Okay. The second bullet says the jellies are counted in 8 different locations throughout Glacier Sea. So as I'm looking at this graphic, I notice that we still have that one area of location right by the house, right by the Glacier Sea Research Center, right by the beach. But I also can see that some samples were taken near the beach and then in the middle of Glacier Sea, off the coast. And so we've got a lot of different locations here. So I'm going to go ahead and add annotations, and I'm going to say 8 location samples. Actually, grammatically, that's not correct. 8 different locations for the samples. And then I'm going to say near the beach and in the, let's see, we want to say maybe near the beach and in deeper water. So we've got a lot, we've got a really good sample here. So I'm going to move that down here so I can remember what this says. And then I'm going to look at my graph here. I can see that this graph looks a lot different than that one. And I can see maybe because I've got more locations, that gives me more samples, and then I get a better understanding of really what's going on over the 30 years that we were taking these samples. So if I look at this graphic, or the graph, it looks like maybe for the first 20 years, population was relatively stable, and then we've got an increase over the last 10 years. That's much different than this one here. So let's go ahead and add that. Looks like for the first 20 years, the population was stable. There was an increase during the last 10 years. Okay, so I'm going to move that. Oh, I don't like when it does that, but whatever. So that's my annotation for those. So if you, let me come back here. Whoops. Continue on. So which provides stronger evidence? Moon jelly evidence card A or B? I'm hoping immediately you say, obviously it's the evidence card B, but why? Well, it's because we've got more samples that we're looking at. And remember, I'm going to come back a couple slides to our evidence criterion. Samples that represent as much of the whole as possible provide stronger evidence. Quite frankly, what we're saying is we've sampled more. We've got more idea of maybe in this one location it was pretty stable, maybe increasing slightly like what we see here. But when we take into account the information that's happening with this individual jellies that are found at these locations, and then we get an average, this gives us a much clearer, much stronger, better picture of what's going on with the population over 30 years. So these graphs showing estimates of population size are based on different samples, and graph B does provide a more accurate estimate of the change in population. Let's go ahead and look at it a little closer, and we can see that it looks like, because it's a straight line, we've got the same number of births and deaths, maybe a little bit of an increase here, a little bit of a decrease here, but whoops, basically for the first 20 years, here's where we started, here's where we ended. So I can say for the first 20 years it's stable, and then over the last 10 years we do have an increase. All right, you guys, I'm going to stop the video for this one. And you guys can just take a really quick little break, and then we'll get started with your homework activity, okay?